All right, so not skipping. We pretty much finished chapter 1 in one day. It's about all it needed. So we're going to chapter 2. Now I pretty much think that y'all already have the idea of what an integer is and what a float, things like that are. So there are some things in here that we're not going to have to spend too much time on. But we need to do due diligence. Now, a difference between this language and Java and C++ is that absolutely every piece of data is an object. Everything is a class, even ints and floats and things like that. They are all objects. They are all classes. In Java, you had the idea, right, of an int, and then you had a wrapper class for an int, capital I integer, or double and then capital D double. And the wrapper class gave you extra functionality. Well, don't need that idea here because the double is a class. So learning about how to declare variables, how to display values, integer data types, floating data types, and arithmetic operators. I bet y'all have each had about 4 classes about how to do arithmetic. X equals 1 plus 2, that kind of stuff. You probably already know that an integer is, a whole number, and a floating point type is something that supports, exponential notation, like 3.4 to the power 7. So it's got a decimal point. Internally, those are completely different data types. The computer stores floating point completely different places. In a completely different format in terms of bit. Even 3.0 is in a completely different bit format than 3, and it treats it internally differently. Now for us, we don't have to worry too much about that. We get to kind of use them interchangeably. Not totally. If it's demanding an int, we can't use a double without converting it. But I don't really care if I say x is equal to 3 times 4, or excuse me, x is equal to y times z. They could be ints or floats, or I can mix those types together. The result in that case would be a floating point type. So, declaring variables. If you remember, in Java, the keyword for declaring a constant was final. Not in this language. This language follows its lead from C++. And then there's the idea of a literal. Its value is taken literally at each use. All right, what is a literal really? If I pretend I'm using Python for the moment. If I use print3, that is a so-called literal constant. Why is it called a constant? Because its value never changes during the running of the program, right? 3 does not magically become 4 unless you edit the code and change that to a 4. So it's a constant. Why is it called a literal? I don't know. I just say it's because you literally type it into the program. I can't think of another reason to call it a literal. So that's a numeric literal. And then, again, this is not C# code. That is a string literal. So 4 would be a numeric literal, which the textbook calls a literal constant. And it's actually an integer numeric literal, right? And this is a string literal constant. Now, I'm not going to keep saying, this is a literal constant, this is a literal constant, this is a literal constant. When I'm typing my code, I might refer to it as a literal. That'd probably be enough most times. But you need to kind of have the idea. You may run into that, those terms again, pursuing a computer science degree or something like that. A constant is something that cannot be changed after the program is compiled. What does that mean? If I have in my code const x equals 4, it means later on, if I try to change the value of x, if later on I change it to 5, or I try to add 1 to it or something like that, the compiler is not going to let that happen because it was declared as a constant. What do you use constants for? Things that should not change. right, the speed of light is a universal constant. It should not change. I could put, it in a constant variable. You can list your constants up at the top of your class or the very first thing inside your main method to make them easy to find. Like the tax rate or whatever. If the tax rate is not supposed to change while the program is running, you might put that in a constant. Or the value of pi. Fortunately, we can get the value of pi from, a class. But if you didn't, then you could say, const. Oh, look at that. What did I do wrong here? This is dumb. Let's pretend that we're actually doing C# now rather than my mutant Python that I was doing. That line would not compile. What did I do wrong?
You didn't declare what it was.
Yeah, I didn't declare what it was. Right. It's an int. Something like that. Anyways, this would be an error because x is a constant. If I wanted this to be able to happen, I'd have to go and remove the word const. So a variable is a named location in memory that can hold different values at different points in time. And just like you've learned before, a variable has 4 components. It's got a name, it's got an address, where it is stored in computer memory, it's got a type, and it's got a value. In this language, every time you create a variable, it's going to have all 4 of these things, but if it's uninitialized, its value may be indeterminate. Right? If we just say int x like this, right? It doesn't really have a value yet. The compiler is kind of keeping track of the fact that it doesn't have a value yet, and if you try to use it, the compiler will fail with an error message saying, uninitialized variable. X has not been initialized, something like that. Depending upon where you declare it, it might have a default value of 0. There's nothing wrong with giving every variable you declare a default value. You don't have to do that. And some editing environments, like NetBeans or Java, give you an error message if you give it a default value and it wasn't necessary, right? If you turn around and assign it a value later. I don't see anything wrong with doing so. So if I did this, int x is equal to 2, I know what the name is. The name is x. The type is int. The value is 2, and the address is unknown to us. We don't really know where it's stored. Now in C++, you can access its address. It's called a pointer. Where are you stored? In C#, you're not supposed to try to get a hold of the address and try to change it via a pointer, because that's unsafe. What do I mean unsafe? When the program runs, it allocates a little bit of memory, right, for itself. You could then, if you had the ability to change a value by its address rather than by its name, you could try to change the value of any byte in the computer. You're not supposed to be changing the value of bytes outside what your application owns. That's a recipe for being able to write a virus or Trojan horse or crashing your program or something like that. Not supposed to happen. The operating system goes to considerable efforts to try to make sure your program cannot modify memory that's owned by another program. So we don't know what the address is. So from now on, I'm going to say that a variable is just something that has a name and a type and a value. Those are the 3 things that are important to us. I may just delete the address. And when you go and, if you're a C++ programmer, you'll remember that it's got an address and you can access it via address. But we're not. We're doing C#. So when you declare your variable, you have to give it a data type. You have to give it a value. And maybe you'll give it a starting value. Excuse me. You have to give it a data type and you have to give it a name. At the very least, I needed to do int x. In this language, you have to declare all your variables before you can use them, unlike some others, where I could just flat out go, okay, y is equal to 7 and 8. It'll automatically create a variable named 8. It would look at this, determine that that variable was an int, Nope. In this language, just like Java and C++, you have to create every variable before it can be referenced. That's called declaring a variable. This is a declaration right there. So intrinsic types, built-in data types. These are your familiar types. your ints and your longs and your doubles, but they are all aliases for classes in the system namespace. You don't really have to worry too much about that, but the reason it's important is that if you're writing stuff in the .NET framework, there are other languages that support .NET, and they all need to be able to interchange their data, and they all need to agree upon how many bits an int is versus how many bits a long is. If you remember when, if you did the C programming language, or if you've done C++, then in some compilers, a long is 32 bits, and in other languages, other compilers, it's 64 bits. Why the difference? Why Microsoft made a long 32 bits where all the other compilers on the planet made them 64? I don't know. But C# eliminates that, those questions by giving us very specific names for the variable types. But then it gives us familiar aliases for it. We can just call it an int or a long or a double. But let's find out what the actual name for a double is in the data type that could be used not just for C# but any other language in the .NET framework. System namespace double, C#. Built-in data types. Double is just a double. Yeah, not very interesting there. But for example, a long is an alias for system int 64, telling us right off the bat that a long is a 64-bit value, right? It can hold larger values than a mere int, which is a system.int32. If you felt like using these variable types in your code, if you wanted to, you could, say, system.int32 is equal to 5, whatever. Feel like doing it that way? That's great. I wouldn't take the time. I'd just say, whoopsie, I forgot to give it a variable name. System.int32y is equal to 5. Or I could just do that, right? They do the exact same thing. I don't particularly see a compelling reason to use the long form of the names. But if you want to be awesome, you could, right? Right, why would I type system.string if I could just use string? On the other hand, maybe it's nice knowing that a short is an int16 as opposed to a long being an int64 and so on. All of the built-in types, except object and string, are called simple types. I'm not really sure the significance of that. Do they not have methods? Let's go ahead and launch Visual Studio, create a C# project, and find out if any of those things have methods. That could be the only possible reason for calling it a simple. Let's create a C#. Why not create a console application? Why not call it Lecture B or C# Lecture B? You don't have to call it C#, but when I run C++ or C and I also call it Lecture B, I get an error saying the project is already created. All right, so I'm going to create a variable x, int x. Now I'm going to try to access its methods, if it has any. X dot, it has methods. Why do they call it a simple type? Not sure. I've forgotten. Maybe it explains it. Now then they suddenly leap topics and they start talking about Unicode. If you do this, if you create a character ch equals single quote, characters have to be defined in apostrophes, not double quotes, x. How about capital A, because I happen to know the ASCII value for that. Ch is really an integer, not a character. Computer doesn't know what a character is. Computer doesn't know what an alphabet is. All it knows is numbers. So this is really an integer containing the value of 65. And if it was a B, it would contain the value 66. And if it was a C, it would contain the value 67. I'm not drawing those values out of a hat. I know that there's something called the Ascii table that specifies that a capital A is a 65 and a capital B is a 66 and so on. And so if you had the word bad in memory, a string of characters, then there would be a sequence of values, a 66, a 65, and a 68, probably followed by a null character to mark the end of the string, so a 0 at the end of that. It's a little bit beyond what we need to know right now, but if you notice, there's no Russian here, and there's no French characters here, there's no German umlauts and diacriticals and stuff like that, right? It's certainly not supporting kanji, Japanese, Chinese characters and stuff like that. The problem is that a character data type in the older languages like C just is 8 bits long. 8 bits meaning that there's only 255 different choices. You cannot fit every alphabet, every character on the planet in 255 characters. Far from it. But what if you had more bits dedicated to it? What if you had 16 bits or 32 bits to it? You could have 65,000 different, letters in all the alphabets, or whatever. And also emoji, all your smileys and, your ships and trains and, all your water droplets, all those things that you send in your phone are also defined in Unicode. So Unicode is just one character set, kind of like the ring in Lord of the Rings, one character set to rule them all, and then the programs bind them. So that way, you could have a character set that had both Russian characters and German characters and kanji and so on, rather than having to switch between them, which is what browsers did in the 90s. I don't know if any of y'all used like Netscape in the 90s, but there was a menu option that would let you switch. This is not an English web page, it's a Russian web page. And if you went to a Russian web page and looked at it, it would look like gobbledygook until you switched it. Nowadays, Russian web pages look great because, our browsers all support Unicode web pages. Might not be able to read it if we don't understand the language. It's not translating it for us. So anyways, that's a 65. Unicode grandfathered in the original ASCII code, which dates back to the 60s, just so that, if we were reading something in and it had a BAD 66, 65, 67, whatever in a row, then it would know that was still BAD in the English language. That's all that Unicode means. It's a system that provides a numeric value for every character. That means that if we were writing C# and we felt like it, we could give our variable names German names with umlauted U's, or whatever. If we had a keyboard that supported that, you could give, Korean variable names and so on. And you could certainly store that kind of data in the literals. All right, a whole bunch of different data types. A character is a 2-byte data. Meaning it occupies 16 bits, meaning that it can hold up to 65,000 different values. A regular old integer can go up to about 2 billion. A long can go up to 9 times 10 to the 18, a far larger value. A double can hold vast, huge values. Pretty much I would just default to using an int and a double unless I find some need otherwise. I don't really have a compelling reason to, if I'm going to count from 1 to 10 to use 8 bytes. Right. An int is the default data type for C# as well as in a lot of other languages. When I come in and I type in x is equal to 3, it treats that as an int. That's just an int. And yeah, you can store it in something else, but it is an int. So why not use that as your default data type? So that's just a prof's recommendation. Why double? Why not float? Right? We're not using longs by default. We're not using the big, double wide int. But instead, we're going to use the big double wide float for our floating point numbers. The reason for that is if we did this, float f is equal to 3.3, 3.3 by default is not a float. Yeah, it's got a decimal point, but it's got a double. The designers of this language and Java and several other languages decided that if there's a decimal point in it, it's going to occupy 64 bits rather than 32. The reason for that is that floating point math is inexact. It can get rounding errors. We could demonstrate that to where, if we just added two numbers together or did some simple division, then it would not give the precise value that we would expect, because base 10 does not cleanly convert to binary, to base 2 when you're dealing in fractional values. What do I mean by that? If you had 1 over, don't type this because I'm going to delete it. If you have 1 over 3, in our language, in our numbering system, it's equal to that, right? But it goes on forever. In our language, in our arithmetic, in base 10, the ratio 1 over 3 cannot be expressed precisely. So, it gets rounded off. And then if you added, that, and you multiplied it by 3, you'd get that, right? Which is not exactly 1. Whereas in our arithmetic, if you took 1/3 times 3, it would equal exactly 1. That's a rounding error. Same thing. If you had, if it's binary, then only powers of 2 could be stored precisely. 1 over 4, 1 over 8. This is just for decimal points. For the whole numbers, any value can be recorded precisely. But for fractional values, that could be stored cleanly. That could be stored cleanly. That could be stored cleanly in that language. But this could not be, right? I don't know if you had 1.6 or 0.6, because that is not an even power of 2, on the bottom of the ratio. So, in order to eliminate rounding errors, not eliminate, to reduce them, so that they don't show up as often, or so that they're minimized, the default data type for floating point literals is a double. So it's giving me an error. You're trying to store a double in a float, because a double is a double wide float, right? It's got more bits. It's more precise. I could cast this to be a float by doing that, but that's kind of lame. There's no reason to be using a float at all if the default data type for floating point values in this language is double. There we go. That's nice. It's not giving me any error messages anymore. So I would just use int and double by default unless there's a reason otherwise. I've never run across a situation where you have to use a float. Now, you may need to use a 64-bit value or a 16-bit value if you're storing into a data structure or writing to a file that demands that only the next 16 bits is dedicated to this number, and then the next 16 bits is dedicated to that number. Then yeah, you might use an int 16, which is a short. But until proven otherwise, just default to using double and int by default. No reason to do so otherwise. So variable declaration, give it a type, a name, and a value. In this language, as in Java and a lot of other languages, the naming recommendation, which you do not have to follow, is start with a lowercase letter, and then for every other word in your variable, capitalize it. Just capitalize the initial one. That's called Camel Case because it's got humps in the middle, right? So patient temperature in Celsius. That's a little bit too long. I would not make a variable name that long, but it shows the point, right? Lowercase p, uppercase, like all that. So you can declare multiple variables of the same type in one line or multiple lines. I could do this, right? If I want to make 4 different ints, int a, comma b, comma c, comma d. Nothing wrong with doing that. On the other hand, if you're going to add comments to your code, it's probably nice to have them all declared separately. Also, if you decide later on that D really needed to be a long, it's easier to change it if it looked like this, right? Typically, I would do this, int a, int b, int c, int d, so that I could give explanations of what each one was, right? This is the number of eggs. This is the the flour in ounces, right? Now it's stupid. I would actually give these variables, better names than just A, B, and C or whatever. But that way I could provide, explanations of what these variables are. Your goal is to make your code as easy to read as possible, so that if another programmer opens your code, then within a minute of looking at it, they pretty much have a good idea of what it's doing. And if you comment your variables, then they have a much higher likelihood of doing that. We should not be using single letter variable names for anything except counters anyways, so this really is lame. But if I was going to use them, I would certainly put comments explaining what they were. So I typically do not do that. Although you could kind of hack the syntax to do something like this. Don't do this. J, comma, K, comma, L. Yeah, you could do that. Take advantage. Ooh, look at that. Oh, I've already defined X. I said K and typed X. One reason to do it like this is later on, if you decided that we were going to have, trillions of eggs, you might want to make that a long instead of an int. It would take more editing to do the same if they had all been grouped into 4. So there may be times when I'm declaring counters that I may, create multiple variables on one line, declare multiple variables on one line. But usually, if they're containing more interesting data than just counters, I'll do that. Create them separately, one per line. Equal sign is the so-called assignment operator. Assigns the value of 3 into the variable x, assigns the value of a into the variable ch. These do not use the assignment operator, so they are uninitialized. If I try to use them, right, d is equal to a plus b, the compiler is going to yell at me because we don't have a value for a and b yet. There we go. It's underlining it, saying, yo, you messed up. So until a and b are assigned values, the code will not even compile. Which is good, because otherwise it could just use random values, whatever data was randomly assigned into it, and it would be unpredictable. The compiler prevents us from making the mistake of using a variable before it has a value. Oh, look at that. I made another mistake. The fact that a is a long means that it cannot be added to an int and stored into an int. So why don't I change this back to an int? See if that corrects this error, but it's not. Okay, now we have a different error, right? It's underlining each variable separately. And it says use of unassigned local variable. Unassigned means uninitialized, means it doesn't have a value. Hasn't been given a value yet with an assignment operator. If I wanted to fix that, I'd have to go, int x equals 0 or whatever value I wanted x to have. Error because a and b are unassigned. When you create a variable and assign it a value at the same time, that's called an initialization. We have initialized x to 3. We have initialized ch to a. But if we then turn around, like down here, and we say c is equal to 4, it's not an initialization, it's just an assignment. Did they give it a fancy word? Did they say? Yeah, it's just an assignment. So this is an initialization because we're giving the value, we're declaring it and giving it a value at the same time. Declare plus assign is equal to initializing. Here, this is just an initialization. No, just an assignment. Now it's real easy to say, okay, we're going to initialize, c to 4, even if it's not the first time. I probably won't say that as often, but I could, you might, mix those terms up a little bit, but we want to know the precise terms as well. That's an initialization. That's an assignment. I might call this merely declaring it, but it's actually, an initialization. Variable name sum money. Assign it 39.45. Do you remember when I last week was trying to have a shortcut that would expand out to the entire word right line? This is not going to work on y'all's most likely. You might try it, anybody using 2019 or 2018 or something, but if I type in CW tab, oh fine, don't do it. Yeah, CW tab, it expands it to console right line. For those of y'all with Visual Studio 2019, try that. Type CW, hit tab a couple times. Does it expand it or does it just leave it as CW? It's like they left that shortcut.
CW and then tab?
Yeah, hit CW and tab or tab. Doesn't expand it. For some reason, after a decade and a half.
Hitting tab twice does.
Oh, pardon me?
Hitting tab twice does.
Oh, okay. It apparently still works. You can give it a shot. I probably won't use it too often because if you're following along with me and you don't remember that. But anyways, typing CW and then hitting tab fills that out. There are other shortcuts as well. If you feel like being a guru and using as many shortcuts as possible, C# shortcuts. We could go and look. Those aren't the ones I want. Oh, come on. Like there's one for creating a constructor with 2 letters, and there's one for creating a for loop, and then another for creating a for loop that counts in reverse, and you can memorize a whole bunch. I guess they're called snippets rather than shortcuts. So you could type in CTOR and it would create a constructor for your class. CW, console right line. Lock, lock a variable. Inbox, insert a simple method. Wonder what that does. If I went up here under class and typed inbox, tab, whoa, creates a message box. If I want to display that in a message box, well, what's a message box? I'm gonna throw that into main just for fun. Then I'll probably delete it, but let's do it. Inbox, tab, fills out. Ooh, now I have not added the forms library to my project, so that's not going to work. I have to create a reference to it. I can't explain within 2 seconds how to do that. I know, you go over, oh, it's right there. This is going far off the beaten path. But say I wanted this to work. What is a message box? It displays a little graphic rather than printing something in the text console. So if I go to references and right click and do add reference, click on references, add reference, I should be able to find, it's wanting me to find system.window.form. System.window.forms. Now if I click OK, it'll add a reference to it, and that error will go away. It would actually compile. It's like a # include. I don't know why we have to have a GUI representation to do that. It didn't add a using up here or anything like that, but it has now added a reference in the project to the system.windows.forms. Now when I run it, it's going to print test. Not print test, it's going to display it in a little window. That's kind of cool, right? Display a little message on the screen rather than, as text up here. If you feel like using message boxes in your class, in your code, you can. Now really, I don't know that we need all this stuff, Right, because we're already bringing in maybe system, right? So maybe we could leave off this first part, you know, make it just windows.form, right? That might work. No, what do you know? Okay, I'm going to undo that and leave it. That's because it doesn't have a using statement up here. If I added a using for system.windows.forms, then I could, you know, shorten it. All right. I can't really think of a reason to print that. If you did not follow those steps precisely and this is still giving you an error, just comment it out. But all I did is I right-clicked on references and added system.windows.forms. So format string, that's when you have that right statement and you got the curly braces indicating what you're printing out. Like this. The money is $, and then inside the curly braces you have a 0 to represent, print out the first parameter there. And then if you had other parameters, you could print out curly brace 1, curly brace 2, curly brace 3. Now, something odd about that is that you don't have to reference them in order. What do I mean by that? If I do right line, oh, do I not have the console dot right line? I thought we agreed that we didn't have to type in the whole thing. And then if I do curly brace 0 in curly brace 1 in curly brace 2 in curly brace, and then put a double quote there, and then end quote, comma, and then fill in 3 values, like double quote A, end quote, double quote B, end quote, double quote C, end quote. It's going to print out ABC. I'm going to comment out this message box because I don't want to have to click OK every single time I run my program. Oh, and it's closing the window as soon as I run it. If I go up to Windows, Start without debugging, it's not going to close the window immediately. There we go. Or I could do and add that, you know, console.readline call to get it to pause. I'm going to do that instead. Down here, close to my closing brace, I'm going to add console.readline, parentheses in parentheses, semicolon. The reason I'm doing that is just so that I can run the program by clicking Start, going into the debugger, and then it waits for me to hit Enter. So I have all these closing braces. I would like to say that this is the end of the main method. This is the end of the class. And this is the end of the namespace. I could give the precise class name and the precise namespace name, but that's enough. And the reason I'm going to do that is I know that eventually as I'm cutting and pasting or moving code or adding if loops and for loops and stuff, I'm going to wind up messing up my curly braces, and that gives me a bit of a chance in advance of figuring that out. Okay, now it's printing out A, B, C in order. What if for some reason we wanted to print them out in reverse order? We could say print the third parameter, followed by the second parameter, followed by the first, and now it's going to print CBA. What if you wanted to print out A 2 times in a row for whatever purposes? Or you wanted to print out the C a second time? I could add another placeholder. 210 curly brace 2 in curly brace. I better do a walkabout and make sure that I haven't gone so far that people have syntax errors. So there we go, right? CBAC. That way I don't have to keep adding parameters here if I'm going to use them multiple times here. Now to me it's kind of weird to be mixing up the order of them, right? If I wanted to print, you know, CBA, why did I just put CBA here? But you can. If you wanted to leave one of them out entirely, What if you did not care about the value of B? You could delete that one entirely. And now it's going to print CAC. Now again, why would I pass it to the write statement if I wasn't going to print it out? Not real sure. Now that I've demonstrated all that, just for simplicity's sake, I'm going to change that back to 0, 1, and 2. But I hope that y'all made those changes and compiled them and ran them just to see how it worked. And it's a good time to pause the recording. Good point. Although it added it, this global colon colon, we don't have to have that there.
It didn't even add it for me.
Pardon me?
It didn't even add it for me. It just kept it like that.
Oh, when you added it, it didn't have global to be. Okay, so if you're using, Visual Studio 2019 rather than 2013, it may not have added a global colon colon reference to begin with. Just a different namespace. But by default, the global namespace is already in there. Okay. All right, if we had this particular error, if I accidentally had two opening braces here like that, rather than close, that's not a syntax error, but it is going to fail. It's a runtime error. It's a runtime error because this is now an invalid formatting string. So if I start it, it's going to blow up. After I click OK, I need to comment out that message box again. And boom, format exception was unhandled. It goes nuts. So I'm going to just stop the debugger and correct it. So I ought to be able to find the stop. Oh, I'm not even seeing. There it is, the little stop, square over here, and then correct it. The debugger is exceptionally useful. We need to cover that soon. So displaying the same value multiple times. I don't think that that's displaying the same value multiple times. Oh, there's an example of it. I have that. So it runs and it says I have $439, and it repeats it 2 more times because it's important. Not sure I'd ever use that in a professional program, but you have the option. Okay. If you want, you can specify how many columns you want to dedicate to that piece of data. I'm going to take this line, comment out the message box like I said I was going to do. I'm going to copy and paste this line, and I'm going to format it differently. First time, I'm just going to put a comma followed by the number of spaces I want it to be padded out to total. So like if I fill in 0, 10, 1, 10, 2, 10, it's going to pad them out so that each one of these pieces of data occupies 10 spaces total. Oh, and each one's still going to have a space between it, so I could remove the spaces and make them 11, something like that, but I'm going to leave that alone. Now when I run it, right, they're padded out so that A fills out 10 spaces, B fills out 10 spaces, and C fills out 10 spaces. What if you want it left justified? Right now they're right justified, right? It's padded out with spaces, and then there's the data. That's right justified. More spaces and then the data. I'm going to copy that and make them left justified. So I'm going to highlight that line. I said I'm going to highlight that line. Then I'm going to paste it. And put a minus sign in front of the width specifier. Now they are left justified. You've seen these ideas in other formatting strings like %d and %, 2d would make d display up to 2 columns, and %-2d would make it, left justified. But a little bit different syntax, same idea. Okay, now they are left justified, right? The data padded out to 10 spaces. The spaces were appended to the data rather than inserted before. Why do you do that? Just so that, the data can line up nicely. Like if we write a for loop and we want all the values, or a while loop, we want all the data to be lined up nicely in a column. So write x is equal to 1, semicolon, while x, while parentheses, x is less than or equal, to, let's make it 1,000,000,000. So I need 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And no, I'm not going to print 1,000,000,000 numbers. I'm going to multiply it by 2 each time. So while parentheses, x less than equals, parentheses, 1 followed by 9 zeros, in parentheses, x equals x times 2. There's a shorter syntax for doing that. I could just do x times equals 2. And now let's write it out. Console dot write line, or if I want to be clever, I could type in, if this works for you, CW tab tab, fills it out to console write line. And now I'm going to make a placeholder to print out the value of x. I want x to occupy like 11 spaces for some reason, or 10 spaces, or 9 spaces, right? Because it's going to go up to 1,000,000,000. Well, 10, because 1,000,000,000 is a 1 followed by 9 zeros. So 10, curly brace, 10 in curly brace, end quote, comma x. But, yeah, that's exactly what I want. I want it to be right justified. Now they're going to all line up nicely against, a border on the right. Or not. What did I do wrong? I'm slightly boggled. Oh, I put that after the read line. It was waiting for me to hit enter. If you did the same mistake, take that read line. I mean, of course you made the same mistake if you were copying me exactly. Cut that and move it after all your code before the curly brace that says close end main. Now it'll do what I want. Ooh, blew up.
Because the 10 isn't the column width, it's the index.
You're right, you're right. It's trying to print out the 11th variable. Sloppy. X is the first variable, so I need it to say curly brace 0, comma 10. The first number being which parameter it is. The second one being the width. Press the little red square to stop debugging. Start it. And there, so you printed them out all nicely lined up. That's why I might want to use, a more sophisticated formatted string. Not just curly brace 0 in curly brace, but, with something specified. When you're printing out a floating point number, you can specify the number of decimal places. You can specify the precision. Right? You might only want to display 3, decimal places, even if the number, goes out to 10, 20 decimal places. Alrighty. I'm going to need to wrap this up in about 5 minutes or so. We're going to have to come up with some clever homework to assign you. Oh yeah, I want to show you, there's a convert class rather than a part class that converts string to numbers. Well, I'd forgotten that. I just use parse as a matter of course, and actually I use try parse as a matter of course. And not Google, do a search for convert. Oh, how nice. It did not demonstrate using Okay, here we go. Convert.toDouble. There is a class called convert that you can use to convert the data rather than using parse like I did last time. So if the book's going to show using convert, I'm going to show using it. My favorite is try parse. The reason I like try parse is that it does not cause an exception if the data is of the wrong format. Like if you accidentally type in a letter when it was expecting a number. If we type in a letter when we're expecting a number, convert.toDouble is going to fail. And let's ask for a value. Console.write. I don't think there's a snippet for console.write. I'm just going to type it all out. Of course, I could do write line and then backspace 4 times. Console.write. Enter the value for A or X. Colon, space, end quote. Close parentheses, semicolon. Now let's read it in. Here's what they want us. No, I guess they read it in 2 different times. You could write it all in one line by embedding the X. Oh, we have to read it into a string. String space S. We're running with lame variable names. S equals console dot read line, capital R, capital L, parentheses in parentheses. Sorry, let me scroll that up. And then we have to convert it. X equals convert dot to int 32. Maybe that's why I don't like it. Anyways, parentheses S. Next lecture, we're going to demonstrate using try parse. And then we could print out whatever we wanted to, right? X squared, right? You know, or whatever we wanted to do with it. We have some data that we could then manipulate. Y is equal to, well, I guess we don't have a variable called Y. Int Y is equal to X times 2. Yeah, we can do something with it. All right, lastly, we're going to create a method. Creating a method is way, ahead of where we're on the chapters, but we know what a function is, or if we've taken another, object-oriented class, we know what a method is. Let's add a method to our little project. Even if the homework doesn't need a method, we need to know how to use it. So way up here at the top under class program, since main is a static method, it's only going to be able to invoke other static methods that are in the same class. So static, same rule as in Java. Int triple, and it's going to take a value in and return 3 times that value. And it's okay if we don't know exactly what this is, although I do expect that you probably know what a function is. So it's going to take a variable, a parameter variable called x, and return 3 times x. So x equals x times 3, semicolon, return x. I like to show things early and often that are an important part of the language. All right. I'm going to use my triple function down here. Remember when I said x equals x times, or y equals x times, let's do int z equals triple, parentheses, x. Right, now it's tripled. And we could print those 2 values out. Console.writeLine, capital L, parentheses, in parentheses, semicolon. Inside those, quote, y equals curly brace 0 in curly brace, and z equals curly brace 1 in curly brace, semicolon. And after the quote, but before the closing parentheses, I need to pass in the variables, the arguments that are going to fill in those two placeholders. So after the quote, comma, y, comma, z. Now when I run it, it should say y is equal to 4 and z is equal to 6. Value of x is 20, so y is 40 and z is 60. If in your assignments you feel like using methods even before they're officially introduced in whatever chapter introduces them, totally cool. Alright guys, I'm going to pause this. I'm going to run downstairs for approximately a minute and I'll be right back. Alright, what that one looks like is it doesn't need the semicolon there. Yeah. And then it needs the curly braces after that. So, close parentheses.
I'm missing the close section there.
Yeah, put the body there. Okay, so while you're typing that in, I might add the homework. All right, it's going to be typical early assignment, conversions. Write a program that converts 98.6, which is kind of the average temperature, although really the average human temperature, you know, is a range. It can even differ from the morning to the evening. From Fahrenheit to C, printing the results. Also, convert 100 yards to meters and print the results. And we need something to actually ask for input. I would declare all these variables as doubles. So what are we going to ask for input? Ask for a number and print out the inverse of the number. For example, if the user enters 10, print out the results of 1 divided by 10. So the inverse is just 1 over, right? Inverse is 1 divided by whatever value they enter. I don't care what you name the variables. All right, 3 little tasks. That ought to be enough. You're going to use console.readLine. We've seen 2 methods of doing conversion. We've seen a parse, but the textbook likes convert. So what kind of conversion are you going to do to convert to a double? Instead of doing convert to int32s, I just need to type this to remember. Don't type it. I'm going to erase it. Convert dot to double. Yeah, okay. So for this task, you know, use console.readline and convert dot. Is it capital T? Scroll down and check real quick. Yep. Difference between C# recommendations and Java is that Java developers typically do not capitalize the first letter of a method. This language does, for whatever reason Microsoft decided to get and convert the input. You could mix those up in one line. You can do this, right? Whatever you're going to call your variable, you know, v is equal to convert dot to double parentheses console dot read line parentheses and then 2 closing parentheses. Right, if you just feel like doing it, writing it in one line rather than 2, it does the same thing. Make sense, gang? All right. So, If you're doing this at home, rather than watching the lecture in class, go ahead and fill out a video review form, upload the code if you typed it in. For those of y'all in lecture, just upload the code. I know you're here. For the homework, I still want screenshots. So once you do the homework, fill in a screenshot as well as uploading the code. Any questions? You still need that.
Let's
All
get
right.
to the ending.
Which ending? Oh, down here now?
Mm-hmm.
Okay.
Yeah, those guys.
Alrighty.